What we are tasked with is we have to inscribe a rectangle under the curve y equals the square root of 9 minus x squared. This equation, like we mentioned last time, is a semicircle. Okay? And that semicircle is drawn there for you. All right? Now, what does it mean to inscribe a rectangle in a curve? That means when you draw your rectangle, the corners of the rectangle have to be touching the circle, the semicircle. That means inscribed. Okay? Now, this is one rectangle that you could draw. Here you could draw different types of rectangles, or different dimensions, right? All right, what are we looking for? We're looking for the dimensions of the rectangle with largest area. And what is the largest area? All right, that tells us again that there isn't only one rectangle I could draw here. That red one is a rectangle. Another rectangle I could draw, let's say, is this one, right? And then, you could imagine you could draw like millions of others, okay? Now, let's just take the red one for a minute. It says we need to find the dimensions of the rectangle with largest area. That means at some point, I need to find the area of a rectangle. Now, back in geometry, you were told that the formula for the area of a rectangle is base times height. Okay? Now, in this rectangle that I've drawn here, this is the base, right? And here is the height. Okay. Because this is not just a rectangle out in outer space. This is a rectangle on a coordinate plane with an equation that it's inscribed into. Everything, our expression for area has to be in terms of x and y coordinates. That's the key. Now, we always solve these problems in the same exact way. The way we do it is this. We say the distance from here to here is x. That would mean, how much is the base? 2x. So here the base is 2x. Now, what about the y? Let's take a look at the y formula. Let's take a look at the height for a minute. Here, the height is this big. Okay? Now, is there a set number to how big that height is? Not really. The height in this case is this big. Well, what if I had another rectangle drawn there? What if I had this rectangle? What's the height now? 380. Well, it's not, okay, so, what about that rectangle? What's the height? I have no clue. How would I find it? How would I find how high that point is? That's what you would do. You would see what the x value is and you would plug it in. So for example, let's take a look at it this way. Suppose my rectangle went from -1 to 1. How would I know how big that is, how high that is? That's f of 1. That's y when x is equal to 1. Okay, let's take a look at it another way. That curve is y, correct? Okay, this is y equals the square root of 9 minus x squared. So let's forget about rectangles for a minute. If I'm at x equals -1, how much is y? What would I do? I plug it into y, right? If x is at -2, how much is y? What do I do? Plug it in. If x is equal to 1, how much is y? What do I do? Plug it in. So now, if the red one is my rectangle, how much is the height? Well, whatever the x is, it's y at that x value. Okay? If this is my rectangle, how much is the height? y, whatever the x is there. Okay? So that means if the base is 2x, the height is y equals the square root of 9 minus x squared. And that's what we're going to get every time you've got a rectangle inscribed in another shape. Okay? Now, I'll take questions here. Any questions? Yes. For the area. We can finally say now that the area is 2x times 9 minus x squared in the square root. Okay? Because we want the rectangle with the largest area, that means take A prime. Okay? So let's rewrite A so that it's in a form that is more simple for us to take a derivative. Okay? Now, can we do U and V for A prime? Okay. So this is U, and V is this. Okay, U prime, and V prime is 1/2 9 minus x squared to the negative half. Right. Right now, I wasn't done yet. So times the derivative of the inside, negative 2x. Now let's simplify that a little bit more. V prime is equal to negative x okay, here we go. Are we good with this? Okay, now let's find A prime. A prime is going to be, right, so U V prime, so it's going to be negative 2x squared 9 minus x squared to the negative half plus, so it's 2x times negative x, and then 2 times to the half. Okay? Now, I think this is where we got to last time, or somewhere around here. Did I switch the order last time? Yeah. So sometimes I do U prime V, and so basically once I get to this point, what I do is like I crisscross, and since they're addition, it doesn't matter which diagonal you go first. Okay, now that's what we had gotten to last time. Okay, this looks sort of complicated, so why don't we factor some stuff out? Why don't I factor out, I'm going to leave the 2 in there, I think. Let's factor out this, 9 minus x squared to the negative half. I'm going to get negative 2x squared, okay, plus 2 times 9 minus x squared times what? To the power of what? 1, right? Because it's going to be half minus half. All right, and then we're going to simplify that. This is now just, you know, like some algebra. So negative 2x squared plus 2x squared, what happens with that? Right. So that's going to be negative 4x squared and then plus an 18. So it's going to be 18 minus 4x squared. Okay? And we hate negative exponents. So why don't I write that as 18 minus 4x squared over 9 minus x squared to the half. If you like, yeah, if you like, that's a root. If that makes you, you know, feel better, because you could see exactly what it looks like, that's totally fine. Well, that's A prime. So we're halfway done solving the problem. Huh? Now I need the critical points. Okay? Right. So now I need the critical points. To find the critical points, The critical points are the points where a prime equals 0 or a prime is undefined. Ooh, look at you guys go. Ooh. Okay, so this is going to be 18 minus 4x squared is equal to 0. 18 equals 4x squared. 18 over 4 equals x squared. So 9 over 2 equals x squared. That means x is, yeah, so it's technically plus or minus root 9 over 2, which is 3 over root 2. However, what is x in the context of this problem? It's half the side of that rectangle, so can it be negative? No. Oh, heavens, no. Remember we said we could leave them? Remember we were like being revolutionaries and we said we could leave them.
Oh, so you always have the numerator equal 0?
Huh?
You always have the numerator equal 0?
Because the denominator is just going to cancel out.
Okay.
Wait, why is it just No, I think you also said
I'm gonna hang on. I'm gonna answer that question in a second. It's negative. It's positive because x stands for the base of the half the side of the rectangle, so it can't be negative.
So your answer
Okay.
always has to be positive.
Yeah. Okay, when you're solving for like physical quantities. Now, back to Jordan's question, you also have to set the denominator equal to 0 because that's where your value, your a prime, is undefined. So from the denominator, though, what do we get? We get that 9 minus x squared is equal to 0. So x is 3. But what is the domain of this problem? Exactly. It goes from 0 to 3. Now, can I have a rectangle that has like an x of 3 though? No. I can't. So the domain is 0 to 3 open, right? Because you can't have.
Why is it 0? Would it be negative?
No, the domain is all the values of x. So the domain is possible values of x. Exactly. X, okay, the domain is the possible values of x. What is x? X is that distance, right? Well, x can't be negative because x still represents a portion of the length of the triangle. You can't have a negative length of a triangle, right? So x can be from 0 to 3, but it can't include 3 because you can't have a rectangle of length 3 here. That's like the maximum. There is no... Exactly. There is no possible. You can't have an x of 0, then you have no rectangle. If you have a 3, there is no room for you to make the sides. Okay? So that's why x equals 3 here, that's not a critical point. So that means since x is equal to 3 over root 2, all right, the base is 2x, so it's 6 over root 2. Okay? Remember, x was half of the base. This is x.
And then we put that x into the
Right. So then what is the height?
Plug the base into.
Uh-huh.
Wait, the base or the 3?
You plug x into there. So y equals 9 minus 3 over 2 squared in a square root.
Isn't it root 2?
Huh?
But it's already root. Oh.
Okay, so, oh yeah, 3 over root 2 squared. I see what you're saying. Yeah, that root is different. So it's 9 minus 9 over 2 in the square root. Mm-hmm. What does it equal?
9 over 2.
The square root of 9 over 2, which is 3 over root 2. Yeah.
How is that? 9 minus.
That's just how the number 9 minus half of 9. 9 minus 9 over 2 is 9 over 2.
Oh, wait, yeah, it is.
Because 9 minus half of 9 is half of 9. All right?
So now you find the area.
So now we need to find the area. Area is base times height. Area is 6 over root 2 times 3 over root 2. Area is 18 over 2, which is 9. No units. No unit. Yeah. Okay, so now we're talking about two numbers which have a sum of 10. So here we said x plus y is equal to 10, right? You have two numbers, x plus y is equal to 10. And then we also said to find the largest sum of the square of one number and the square root of the other number. All right? And then we said we can't have an equation with x and y. All right? We will later, but not now. So we said we need to be able to solve one variable for the other to make one go away. So I came back here to the left and I said, okay, why don't we solve this for y? And we got y equals 10 minus x. Okay? So then I went back and I said, okay, x squared plus root y is x squared plus the square root of 10 minus x. And then, you know, I wrote it in a better form for me to be able to take a derivative. Once I have my f of x, think back to what it is that you want to find. You want to find the largest sum. Again, we're looking for the maximum sum. When you're looking for the maximum of a quantity or the minimum of a quantity, you want f prime and then you want to find what of the derivative, from the derivative? Critical points. So here I took, you know, a derivative of f and I got a critical point of this. Okay? Yeah, it's fine. So we're going to put it in here. Okay? We're going to put it in here on our number line. Now look at what our domain is. Our domain goes from 0 to 10. Yeah, we are fine. So then we want to do the sign chart here. So you want to know in here, is it like positive or negative or what, right? So let's pick a region on the right. Let's pick a number from the region on the right. So let's say like 5 it is, okay? 5 it is. When we put it into, what do we put it into? F prime. Yeah. When we put it into f prime, what do we get? If it's 5, it's 2 times 5 minus 1 over the square root of 1 over 2 root 10 minus 5. So that's 10 minus 1 over 2 root 5. Okay? How much is that? It's positive, right? You guys we're good that it's positive? Okay.
You don't need to know the actual
Right, you don't need to know the actual value. Okay. What about a number from the left? Give me a number. 0.06. How about 0.01? Let's do 0.01, just because 1 is better than 6. So what if it's 0.01? It'll be 2 times 0.01 minus 1 over 2, 10 minus 0.01. So that's 0.02 minus 1 over that tiny little number. How much is that? Why don't we try this out?
What's the point of doing this if we already have x?
Because we want to know, we want to make sure that it's a, yeah.
2 square root.
Oh yeah, square root. Huh?
The one that's not available. Shouldn't if we get that answer it automatically be?
Yeah.
No, I know, but
So what do we get here? Okay. Now, what was it that we were looking for? We were looking for two numbers, x and a y, right? So x we got 0.07. And what about y? What is y going to be? 10 minus x. So that's going to be 10 minus 0.07. How much is that? 9.03 or 93? 9.93. All right, so that's your x and y. Okay?
And after that, we're done?
After that, you're done. And the homework for this will be a handout.